This is an overview of the Analog Devices Single-Phase Energy Measurement IC. Welcome to the training module on the ADE 71XX and the ADE 75XX. This training module introduces the features and a block diagram of the single-phase energy meter IC along with its peripheral interface. The Analog Devices IC ADE family combines industry-leading data conversion technology with a fixed-function digital signal processor, DSP, to perform the calculations essential to an electronic energy meter. The portfolio includes single-phase products and polyphase products for stepper motor and LCD display meter designs, with 5 critical measurements available, including wattage, RMS voltage, RMS current, VA, and VAR. ADI has added to the portfolio the ADE 71XX and ADE 75XX product families that simplify energy meter design by providing all the features needed for an accurate, reliable, and fully functional energy meter with LCD display in a single IC. The ADE measurement core includes active, reactive, and apparent energy calculations, as well as voltage and current RMS measurements. This information is accessible for energy billing by using the built-in energy scalars. Many powerline supervisory features such as sag, peak, and zero crossing are included in the energy measurement DSP to simplify energy meter design. The microprocessor functionality includes a single-cycle 8052 core, a real-time clock with a power supply backup pin, an SPI or I2C interface, and a UART interface. This device has 2 power supply inputs, VDD and V battery, which require only a single 3.3 volt power supply at VDD for full operation. A battery backup or secondary power supply with a maximum of 3.7 volts can be connected to the VBAT input. Internally, the ADE connect VDD or VBAT to VSW out, which is used to derive power for the device circuitry. The VSW out output pin reflects the voltage at the internal power supply, VSW out, and has a maximum output current of 6 milliamps. The ADE module provides an automatic battery switchover between VDD and VBAT based on the voltage level detected at VDD or VDC in. In an energy meter application, the 3.3 volt power supply, VDD, is typically generated from the AC line voltage and regulated to 3.3 volts by voltage regulator IC. The pre-regulated DC voltage, typically 5 volts to 12 volts, can be connected to VDC in through a resistor divider. A 3.6 volt battery can be connected to VBAT. A sequence of events will occur if the main power supply generated by the PSU starts to fail in the power meter application. This page gives you information about the operating modes of this device. The operating mode of the ADE is determined by the power supply connected to VSW out. Therefore, changes in the power supply, such as when VSW out switches from VDD to VBAT, or when VSW out switches to VDD, alter the operating mode. There are 3 operating modes: normal mode, battery mode, sleep mode. If any of the enabled battery switchover events occur, VSW out switches to VBAT. This switchover results in a transition from PSM0 to PSM1 operating mode. To reduce power consumption when VSW out is connected to VBAT, user code can initiate sleep mode PSM2 by setting bit 4 in the power control SFR register. This page gives you the energy meter system diagram. ADE has 175 million units deployed in the field. ADI has added to the portfolio of the ADE 71XX and 75XX product families that simplify energy meter design by providing all the features needed for an accurate, reliable, and fully functional energy meter with LCD display and a single IC. It integrates the main functions of an LCD meter with IR port and RS-485 communications, battery backup, 2 current sensors, anti-tamper interface, and EEPROM interface, while using the features of the ADE 71XX and ADE 75XX series, such as battery management, anti-tamper detection, temperature compensated real-time clock, and LCD driver contrast. The ADE 71XX and ADE 75XX family has a unique LCD driver capable of maintaining maximum contrast on the LCD independently of the power supply level using charge pump circuitry. This technology, combined with the on-chip temperature measurement, enables the lowest power operation and maximum readability of the energy meter LCD display. The ADE 71XX, ADE 75XX family has unique battery management features, enabling low power consumption in battery mode and optimal power supply management when the voltage is lost. The ADE indicates when the power is below the no-load threshold by holding the calibration frequency pin high. This is useful to indicate a tampering or a miswired condition. The ADE 71XX/ADE 75XX family provides a low-power RTC with nominal and temperature-dependent crystal frequency compensation capabilities, enabling low drift and high accuracy timekeeping. The RTC functionality is also maintained at low power supply voltages of 2.4 volts and over all power supply connections, extending the operating life of the energy meter in battery mode. By default, the RTC is maintained active in all power-saving modes. The RTC counters retain their value through watchdog resets and external resets. They are only reset during a power-on reset. In this page we show the ADC and signal processing chain for the current channel. In waveform sampling mode, the ADC outputs a signed 2's complement 24-bit data word and a maximum of 25.6 kilosamples per second. For conventional current sensors, a simple RC filter, single-pole LPF with a corner frequency of 10 kHz produces an attenuation of approximately 40 dB at a 819.2 kHz. In this page we again show the ADC and signal processing chain for the voltage channel. In waveform sampling mode, the ADC outputs a signed 2's complement 24-bit data word at a maximum of 25.6 kilosamples per second. The ADC produces an output code that is approximately between 10,485 decimal and minus 10,485 decimal. When in waveform sampling mode, one of 4 output sample rates can be chosen by using the DT-RT 0 through 1 bits of the WAV-MODE register. The output sample rate can be 25.6 kilosamples per second, 12.8 kilosamples per second, 6.4 kilosamples per second, or 3.2 kilosamples per second. If the WFSM enable bit is set in the interrupt enable bit 3 SFR register, the 8052 core has a pending ADE interrupt. The ADE has an 8052 MCU core and uses the 8052 instruction set. Some of the standard 8052 peripherals, such as the UART, have been enhanced. The special function register SFR space is mapped into the upper 128 bytes of internal data memory space and is accessed by direct addressing only. It provides an interface between the CPU and all on-chip peripherals. This page shows a block diagram for the multifunction meter with advanced power quality analysis. Current and voltage is sensed through respective current sensor and ADC, and the signal is amplified and passed through several filters for signal processing, which should be in a form to measure through the processor. The processor is interfaced to EEPROM, the temperature sensor, RTC, LCD drivers, and also to communication blocks like RS-232, PLC, PSTN in order to give proper measurements. The ADE 71XX and ADE 75XX family of products share a common set of tools designed to minimize design time while improving part understanding. The energy meter reference design integrates the main functions of an LCD meter with IR port and RS-485 communication, battery backup, 2 current sensors, anti-tamper interface, and EEPROM interface, while using the features of the ADE 71XX and ADE 75XX series, such as a battery management unit, anti-tamper detection, temperature compensated real-time clock, and LCD driver contrast.